Welcome to Brain Vision.
So in this question, we are taught to explain how to write the electron configuration for an element based on its position in the periodic table. So to determine the electron configuration of an element on the periodic table, we can write the inner configuration of the element by knowing the noble gas that precedes it. And the inner configuration is equal to the configuration of noble gas. The outer configuration is obtained by counting the number of electrons between the noble gas and the element and assigning the electron to the appropriate orbitals. The highest n value is given by the number of rows. So for example, if we look at the periodic table and we decide to choose an element, for example, if we choose oxygen, so if we choose oxygen and the atomic number is 8 and the mass number is 16, oxygen, the noble gas that precedes oxygen is helium, so we can write it as helium, right? And we know that helium is 1s2, right? Then we know that oxygen is in the second period. That means that the number of n, the n value for oxygen is 2. That is the outermost shell value for oxygen is 2. We've written the inner core, which is the noble gas, to be helium, and it has the 1s2. So because oxygen has outer shell in the second row, so it has to be 2. And then the 2 has the 2s and it also has the 2p. Now if you look at the group number of oxygen, it's in group 6, right? So being in group 6, and it's also in the p block, and it is in the 4th p block, so that means it has a p4 configuration, 2p4 configuration, and it will have 2s, because if you have a p4 already been filled, then you should have the 2s also filled. And if you count it all together, this is going to be 2 plus 2 plus 4, that's going to be 8, which is the atomic number of oxygen.